Hi, this is a short screencast that will talk about special angles. Special angles. Now, what are special angles? These are angles that you can easily calculate the trig values without the use of the calculator. For example, sine 60, cosine 60, tangent 60, sine 30, cosine 30, tangent 30, sine 45, cosine 45, tangent 45. Now, these are not given in the formula booklet, so at some point you need to remember how to get this. Now, I know that some of you may have mentioned that you will need to remember or memorize. You don't really have to memorize. But one thing I want to just mention briefly is, I want to just let you know what these values are, and then I'm going to prove to you as to how you can solve them. So on the day of a test or an exam, like, oh, I don't remember what sine 45 is. Well, I can show you how to get that without the use of the calculator. But first and foremost, let's just fill this up. So sine 60 is root 3 over 2. Cosine 60 is a half. Tangent 60 is root 3. Sine 30 is 0.5 or half. Cosine 30 is root 3 over 2. And tangent 30 is 1 over root 3. Sine 45 is 1 over root 2 or root 2 over 2. Now, cosine 45, same thing, 1 over root 2 or square root 2 over 2. Tangent 45 is 1. Now, how did I manage to do this so quickly? Well, I've been doing this for a long time. Number 2, there is a way that you can actually do this on your own. You don't have to worry about memorizing specifically, but it might help to remember these things. But I'm going to show you how easy it is to get these values. Okay, so let's take the next slide. Okay, so now I'm going to have an equilateral triangle. Well, what is an equilateral triangle? Well, an equilateral triangle is a triangle where all sides are equal to each other. Let's assume I take an equilateral triangle that is 2 centimeters long on each of the sides. It could have been anything, right? But I'm just choosing it to be 2. It's easy. Notice that if it's an equilateral triangle, this angle here is 60 degrees. All of these angles are 60 degrees. Now, next thing I want to do is I'm going to draw a perpendicular line, all right, where this is what we call the midpoint. This is now going to be 1 centimeter each length, from here to here, and 1 centimeter right from here to here. So I want you to focus on only this part of a triangle. So I'm going to redraw this. Notice, this is 1. This I don't know. This I know is 2 centimeters. Now, I'm interested in this. So this is 60 degrees, right? Now, if this is 60 degrees, what is sine 60? Well, sine 60 is given to us as opposite over hypo. This is opposite, this is hypo, and this is adjacent. Well, what's opposite? Well, I don't have opposite, so I need to find opposite. So I use Pythagoras' theorem here. So I'm going to call this x. So I'm going to say x squared plus 1 squared equals to 2 squared. X squared plus 1 squared is equals to 2 squared. Pythagoras' theorem. So x squared is 4 minus 1. X equals to square root of 3. So this is root 3. Okay. Now what? What's opposite? Well, opposite is root 3 over hypo. So that's root 3 over 2, which is what I did just now. Now, if you use your calculator, that value is 0.866 ... Now, how do I do that? Well, here you go. So sine 60 and that's it, right? So remember, this has to be in the degree mode. This is only possible if this value here is in the degree mode. This has to be in the degree mode. You got to be careful. If it's not in the degree mode, you will not get that correct value. So now, what about cosine 60 then? Well, cosine 60 is just adjacent over hypo, and that's just 1 over 2. And tangent 60, well, tangent 60 is just opposite over adjacent. Well, what's opposite over adjacent? Well, opposite is square root 3, and adjacent is 1. So the length is root 3. All right? So now the question is, how do I compute sine 30, cosine 30, and tangent 30? All right. So sine 30, this time, this is the angle. So it's kind of messy, so I'm going to just do it on a new slide. So same triangle, root 3, 1, and 2. Except instead of 60 degrees, this is 90, this is 60, this has got to be 30. Now, this becomes the adjacent. This becomes the opposite. This becomes the hypo. So, what's sine 30? Well, sine 30 is opposite over hypo. That's 1 over 2. What's cosine 30? Well, that's adjacent over hypo. That's adjacent over hypo. That's root 3 over 2. And what's tangent 30? Well, tangent 30 will just be opposite over adjacent. And opposite over adjacent will be what? 1 over root 3. Okay? So we've done with the special angles for 60 and 30 degrees. And remember, this is in degrees, right? You could have this entire thing as in radian. So if it's radian, it will be sine pi over 6. And that's just going to be half. Cosine pi over 6. That's root 3 over 2. So that's something that you should be able to do if you understand the conversion between degree and the radian mode. All right. So what about this now? What about sine 45? What about cosine 45? What about tangent 45? Well, let's get ready for the next slide then. Okay, so now a completely different triangle. Now, I am now going to get a triangle that is an isosceles triangle, not an equilateral. What is the advantage of an isosceles triangle? So let's say if it's a right isosceles triangle. So this is 45 degrees. All right, this is also 45 degrees. Let's say this is 2 centimeters. All right. Let me think about this. Let me pause for a second. Okay. So what I'm going to do is I'm going to make a small little change. I'm going to just, let's see what happens here. Oh, no. Let me just do this. Sorry about that. Okay, now. Oops. All right, so now what I need What I do really need is a cup of coffee. Now, I'll do that shortly. Have that coffee. But in the meantime, let me finish this. I have a right isosceles triangle. So suppose if it's a right isosceles triangle, this is 1 centimeter by 1 centimeter. It's an isosceles right angle triangle. So these values are equal to each other. 45 degrees, 45 degrees. All right, so a right isosceles triangle. Now, so let me just draw it a little bigger. No, that didn't work out right. So let me just draw it again. Okay, now, so this is 1, this is 1, this is 45 degrees. Now, I don't have to write this, I just need one of the angles. So, if this is 1, what is this value here? Well, think about it. This is using Pythagoras' theorem. X squared equals 1 squared plus 1 squared. X squared equals to 2. X equals to root of 2. So, square root of 2. Now, what's sine 45? Well, sine 45, if you recall, is opposite over hypo. And what's opposite? Well, this is opposite. This is adjacent. And this is hypo. So opposite over hypo. So opposite is 1, hypo is root 2. Right? And now remember, earlier I had mentioned that it's equivalent to this as well. That's root 2 over 2, that's 2. Now, whether you write it as 1 over root 2 or root 2 over 2, it's entirely up to you. Cosine 45. Now, cosine 45 is, again, adjacent, which is this, over hypo, which is here. Adjacent is 1 over root 2. All right? And tangent 45. Tangent 45 is opposite over adjacent. That's opposite is 1. Adjacent is also 1. And that's 1. All right? So this is how you calculate the special angles. So I hope you found this useful. Any questions? And you're very welcome to give me feedback. Always welcome feedback. Any questions regarding the special angles, do let me know. Thank you very much.